Hello Algebra 1 students, this is Mr. Wilsey. In this video we're going to continue looking at the Algebra 1 practice EOC starting with number 11 here. So you need to be taking down notes or doing the problems ahead of me on your own paper or on the printed out version of these problems, whichever you have access to. Alright, so number 11 is a compound inequality that we have to solve. Right? It's compound because it has two different unequal relationships here. Now, what is particularly difficult about this one is that you have an x on the far left side of the compound inequality and an x on the far right side. So this problem really requires you to recognize that you can split the inequality. This is one inequality. 20x minus 18 is less than 50. And then this is a second inequality. 50 is less than 36x minus 16. So these are two separate inequalities that you can solve to find a value for x. I think when you solve the first one, you'll get 68 divided by 20, whatever that is. Can simplify that fraction. The bottom one, it looks like you will get x is greater than 66 divided by 36. Okay, so both of those fractions you can simplify, and you should wind up with an answer of A. Alright, now let's go ahead and look at number 12. I assume that you can read, so I won't read this problem to you, but we start out with this function here. P equals 1000 plus 0.05 times t. Now, after reading through this situation, 1000 is how much she earns each month, regardless if she makes a sale or not. But if t is the amount of sales that she makes, you multiply that amount by 5%. In order to get the commission that she makes. And this is the commission. It's an extra amount that she earns on top of the $1,000 based on the amount of sales that she makes. So we are asked if her commission increases by 2%, what will be the new function representing this situation? Well, the answer to this will be J. The answer is J because you can see that the commission amount increased by 0.02. So this was 0.05 plus the extra 0.02. Now, the 1,000 did not change. The flat amount that she earns each month does not increase at all, doesn't change. All right? So 12 is J. Let's look at number 13 now. Number 13, we are given a graph of a relation. So this is the graph right here. And then we are asked which of these sets of ordered pairs is included in the relation. Now this is a really easy problem to answer. All you really need to do is plot each of the points in A and check to see if those points lie on the graph. And then do the same thing for B, C, and D. So for example, if we plot A, -3, -3. So the first point in A is in the relation. 0,3 is right here. Well, that point is not in the relation. Neither is the next point, 3,1. So you know immediately that A cannot be the answer because not all three of the points are in the relation. It will turn out that the answer is C. Because if you plot all three of those points, they will lie on the graph. Ta-da! In number 14 now, I hope that you've locked in your answer choice, because we're going to look at it together now. We want to write a linear function that represents this table of values here. Now remember how we find the two parts of a linear function. How do we find the slope And then how do we find the y-intercept? Well, let's first of all start with the slope. The way that we find the slope is by looking at how much the value of the function changes each time the value of the independent variable goes up by 1. So in each of these rows, n increases by 1. That's really, really nice because it makes it easy to find out what the slope is. The function increases from 4 to 11, which is an increase of 7. It increases by 7 again, and again, and again. So the function increases by 7 each time the independent variable, n, increases by 1. So the slope is positive 7. So that is the number that will multiply the n. 7 must multiply n. Answer choice J here is the only one that has a 7 multiplying the n. Now, just in case you were curious where the -3 comes from, recall that that number comes from the value of the function when n is 0. So if we go back 1, then the value of the function must go down by 7. 4 minus 7 gives the value of the function of -3 when n is 0. So that means that the y-intercept is -3, which is exactly what we have down here. Alright, now let's go ahead and look at number 15 together. We are given 4 different graphs, and we are asked to determine which one of these graphs does not represent a function. Now, recall that if we're looking at graphs, in order for a graph to represent a function, it must pass what we call the vertical line test. So if a graph passes the vertical line test, it is a function. So remember that the vertical line test says that if we have a vertical line and we slide it, does it intersect the graph in only one place? Well, for graph A, yes. If we slide this vertical line across, it will only ever intersect the graph at one point. So graph A does represent a function. Now let's go ahead and test C. If we slide this vertical line across, it will only ever intersect at one point. So C is a function. Okay, now let's go ahead and test the next one. B is also a function. Now let's check D. D is kind of weird. Oops. My vertical line is no longer vertical. It's cheating. D is a little bit weird because D is a vertical line. If you have two vertical lines, they intersect everywhere. They intersect at an infinite number of points. So D is about as far away from being a function as possible. So D is not a function, which means that it is the correct answer choice. Okay, now let's look at number 16. In number 16, we have two binomials, and we are asked to multiply the binomials. Now, remember we learned a couple different methods for doing this. One of them was the box method, for example. So you could fill it out like so. X, -k, y, and -k. Or you could use FOIL. So multiply the first, the outside, the inner terms, and the last two terms. Or double distribute was the other method. I'm going to use the box method over here. Okay. Now notice how I filled out the grid. I made sure to include the signs here. So what we're doing in this area is multiplying. So in this center box, this is going to be the result of multiplying x by y. Well, really the only thing we can say is that it's xy, right? Notice that I put the x in front of the y. That's just standard, right? You write the letters in alphabetical order if you're multiplying letters. So x times y is xy. Over in this box is going to be negative ky. In this box is going to be negative kx. And then in this box is going to be negative k times negative k. And what is that equal to? Positive k squared. So now that we have all of these terms, we add them up. So xy plus a negative ky plus a negative kx plus k squared. Now which answer choices does this correspond to? Well, it looks like in the answer choices they put the x in front of the k, which is weird, but hopefully you can pretty easily match this with answer choice H. Okay, they're following kind of a different convention as far as what letter goes first. But you know that the order of the two factors here does not matter because they're being multiplied. So it doesn't matter if you put ky or yk. Okay? So notice how what we found here matches answer choice H. Alright, now let's look at number 17. Number 17 is one of your favorite types of problems, I know. This is a rational expression. Remember rational expressions, first step is to factor the top and bottom of the fraction as much as you can. Second step is to cancel. Okay, so let's go ahead and look at just the top part of the fraction for now. Let us try to factor that. Well, we can use the shortcut to factor that because there's no thing multiplying the x squared. So the way we're going to factor it is two sets of parentheses multiplying each other, x and x. What numbers go here? Well, let's see. What two numbers multiplied equal 28? Add up to equal negative 11. 7 and 4? Yeah, so negative 7 and negative 4 will work because they'll multiply to equal a positive and they will add up to equal a negative 11. Okay, so that's how we factor the top. Now let's factor the bottom. Again, we can use the shortcut. So x and x. Now what two numbers multiply to equal negative 21, add to equal negative 4? Let's see. Negative 7, positive 3. Does that work? Negative 7 and positive 3. Yeah, that works. All right, double check me on it. So final step is to cancel. All right, we just got finished factoring. Now we cancel. Well, there's an x minus 7 on the top and an x minus 7 on the bottom. So those guys can be canceled out. And that leaves us with x minus 4 over x plus 3. Which answer choice is that? Well, we have C and D to choose from. So the final step is to determine what are the restrictions on the domain. Now this is the same exact thing as asking what are the excluded values. You should be a pro at finding the excluded values of a rational expression by now. The easiest place to look is right here at this expression. Now remember that a number is an excluded value if it makes the bottom of the fraction equal to 0. So we're asking what will make this part of the fraction equal to 0. Well, I hope that you see that it could either be a positive 7, so x could be positive 7, or x could be negative 3. And because we don't want the bottom to equal 0, because that'll make the whole expression explode into infinity, that means that we're going to write it like this. X cannot be equal to 7, or x cannot be equal to negative 3. Actually, that should be an and. Okay? So those are our two excluded values. Those are the two restrictions on the domain of this rational expression. So now we can narrow it down even further. The answer choice is C. I hope that's the answer choice you picked. Alright, number 18 is up next. So we are given this weird looking shape, and we're given some of the dimensions of the sides of this shape, and we are asked what is the length of x. And all of our answers are given as radicals. Ew, radicals. I know you love radicals. So how in the world are we going to find x? Well, just looking at this shape, I hope that you can see a triangle. Do you see a triangle in here that might help us figure out what x is? Here's the triangle. Here's a triangle that I see at least. Yeah? So we know that the hypotenuse of that triangle is x. And what's the length of this side right here? Well, we know that this whole length is 21, and this length is 13, so the length of just the orange highlighted part is going to be 21 minus 13, which is 8. And similarly, we can find the length of this side right here by taking 9 minus 5, which is 4. Okay? So we have ourselves a right triangle. And you know how to find the length of the hypotenuse. If you know the lengths of the two sides of the triangle, you need to use the Pythagorean theorem. So what we would write is 8 squared plus 4 squared equals x squared. So once we have this, 8 squared is 64, 4 squared is 16, 64 plus 16 is 80. Now, in order to find what x is, what do you have to do to both sides of the equation? You have to square root. So if we square root both sides, that means that x is equal to the square root of 80. Now the square root of 80 is not one of your answer choices, because all of these answer choices are simplified radicals. Now what you could do is use a calculator. Okay? Calculate this as a decimal. Let me do it real quick. Square root of 80, 8.94. So this is about 8.94. And then you could approximate all of these as decimals and see which one is closest. But if you want to actually simplify it the way that I taught you in class, what you would do is say, all right, 80. What is the largest perfect square factor of 80? Is it 16? I think it is. What happens if we take out a 16, if we factor out a 16? 16 times what equals 80? Well, I think that it is 5. Once we have this, we can take 16 out of the radical, but when it comes out, we have to square root it. So the square root of the 16 gives 4. But now it has successfully escaped the radical, but it left its poor little friend, number 5, inside the radical. Okay? So this is the simplified form. 4 times the square root of 5. Which answer choice is that? G. Bam! Done. Alright, number 19. We are asked to write a function that represents this situation. So we want to write a function that tells us how much it costs to rent a truck if we drive it n miles. Now, $40 here is the one-time fee. So $40 is going to be in the function. Now, for each mile we drive, we add 75 cents, or $0.75, for each mile that we drive. Now, the key is this phrase right here, for each. That means that each time we drive an extra mile, we add this amount, 75 cents. So that is the key that tells us that 0.75 multiplies n. Okay? Each time n goes up by 1, we add 75 cents. And then to finish the function, t equals, the total cost equals that. So this is letter choice A. That's the correct one. I hope that this is pretty clear. All right, number 20. You actually will not see problems like this on the end of course test, so I won't teach you how to do it. But if you're curious, the answer choice is J. All right, finally, that's it with this video. Hope that it was helpful for you and that you are ready to start practicing some problems that are similar to this. Check with Mr. Wolsey to see if he's got that ready for you. And good luck on the end of course test.